Morning. Welcome to Detnet. I'm Lou Berger. This is Pat Taylor, my co-chair. Before we really get started, I want to remind people we're going to be using Etherpad to take notes, and we invite you to join. Unfortunately, I don't have a link on the screen. The easiest way to get there is to go to tools.ietf.org/wg/detnet and click under minutes, and you'll find that there's a Etherpad 99. So tools.ietf.org is the easiest way to get to that. For agenda information, slides, you can also find it at the usual data tracker location. We're later in the week, so you should be familiar with the Note Well. Hopefully people have pointed out that this Note Well is subtly different from the old Note Well. The major difference is we have a new RFC guiding IPR disclosures. As usual, if you contribute to an activity in the IETF and you're aware of IPR, you are obligated to disclose that IPR. If you're unwilling to disclose that IPR, you cannot contribute. Here's the long form pointer to Etherpad. Again, the short form is off of tools.ietf.org. We are audio streaming and using Meet Echo. There are people remote. Also, to help the note takers, please remember to state your name when you come to the mic. We're up to 5 people on Etherpad. That's great, but please, others join in. It's a great place to verify that your comments were appropriately captured, or to help the group out to make sure we appropriately capture the discussion. Blue sheets should be circulating now. As usual, put your name on there. We have, 7 topics on the agenda. The main focus today is really going to be on data plane, both on encapsulation and beginning the discussion on service semantics and traffic treatment parameters. To help us with that discussion, we're going to end the session with some information from the 802.1 TSN active participants, and they will focus on what's happening there in the area of traffic treatment and queuing and service parameters, as well as some other general information. We do have a mailing list, as everyone else in the IETF does. Please feel free to use it for any discussion topic related to the working group. So where do we stand on documents? We have the architecture has been recently updated. We're going to hear from Norm on that update. The big question on that document is how close are we? And we will be asking whether or not we're ready for last call or what it'll take to get us to last call, particularly on the architecture document. The use cases, it's pretty mature as well, but to some degree there's less of a rush to close the door on that, because as we talk about Detnet, some new use cases come in, or old use cases are re-raised in subtly different ways. And by keeping the document around and active, it allows us to tweak it as needed. But at some point, we have to decide that it's time to ship it. Frankly, it doesn't define a technology, so it's a little less important to get that one completed. We can let it, once we find that we haven't revved it in a little while, we'll say that it's done and push it out. We have a couple of expired documents. We have the alternatives, which were really helpful to get us to the solution document we're going to be talking about. Whether that's published as an RFC or not, it's not so critical, as we discussed last time. But the problem statement, that's worthwhile to publish. Now that we have an architecture document that seems to be close to ready, perhaps it's time to last call this document as well. So we will be moving that way. So we're going to ask the authors to rev it to make sure that it's not expired, and the working group to review that document, and we'll go through a formal last call on it. So just as a reminder, we have 4 core deliverables. We are going to be talking about 3 of them today. The 4th we've yet to receive proposals on. It's okay that we haven't received that because to some degree it's blocked by the information model. One of the things to consider for the working group is if including the service definition and traffic treatment parameters in the info document is the right place for that. Our plan right now is to have that bundled in, but we've been hearing that people have been missing the fact that there is a Detnet, or we're expecting to have a Detnet service definition. And perhaps if we break that out into a separate document, that might help people focus on that. That's just something to consider. It's a document reorganization. It shouldn't speed anything up. It shouldn't slow anything down by doing that, but it would just help for the visibility and readability. So that's just something for the working group and the authors to consider as we move forward. We do have a security document. It's also on the agenda. And we'd like to ask the question is, are we ready for adoption on that? Questions, comments? Agenda bash? Great, thank you. So we're going to move on now to the architecture document. Norm? Norm? Norm.
Clicker.
Norm Finn. The authors on the draft, of course, are Pascal Tubert of Cisco, Balazs Varga, and Janos Farkas of Ericsson.
Norm, if there's a monitor down there.
That's easier to look at. Yeah. So, summary of the changes from draft 1 to draft 2. That's from March to June. The biggest change when you look at the diff is a bunch of stuff has moved around to organize it better so it made better reading. We added a few smaller chunks, a bit about data plane overview. There's a bit about the difference between the different kinds of nodes, explaining that further, that we have edge, relay, and transit nodes. And we added a section about packet encoding for service protection, which is interesting. You'll see why that's interesting in a couple of slides. And all the changes were for clarity. There's no substantive changes to the architecture. It works about the same as we thought it would work in March. Now, where are we now? This diagram is from the architecture. It shows one of the major use cases, where we have a TSNN system going into an edge node through a transit network and out to an end system on the other side, and it shows where the subnetworks are, where direct links are. It gives a pretty general use case for what we're trying to accomplish with Detnet, which is the zero congestion loss and the extremely low packet loss. So how far have we gotten on that? We have a section in the architecture, section 3 for provisioning the quality of service. We have a section for the stack model for what the organization of the functions are in the end station. We have the description of all of the pieces, all of the boxes that are part of the system. We have the description of the flows, what they look like. We have the how we manage to do the traffic engineering to get the quality of service. We have the queuing, shaping, and preemption. We have the low-level mechanisms that we need to actually deliver the service that we're trying to get, and those low-level mechanisms are important. We have the definition of what an instance of the service looks like, so that we've got a good architectural model. We understand how to identify the flows so that we can give them the particular treatment that each flow requires. And we have the other pieces. This diagram Balazs did, I thought it was a very effective way of showing what we need to do and what we've done. And we think we've covered everything in the architecture that we need to cover. There is one section in the document that says this section will be removed for working call, for last call. And it includes some stuff that people have brought up, but that we have, in our conversations, have not taken any further, either because we think they're bad, because the authors of the various drafts that we have think they're not important, or because someone thought they were important but hasn't pursued it by actually coming up with some text and describing how to do that. And interestingly, one of those is 5.4, which was just added. They were placeholders for ideas that people had, and I think they've been overtaken by events. So the proposal, when I say the design team, the people working on this, the authors of the drafts that I know of, we don't anticipate any significant changes. So we suggest that we remove section 5, the placeholder for ideas that didn't mature, and that it's time for a working group last call on this document. If we're missing something, we want to hear about it. We will remove the plan right now, remove section 5 as soon as the data tracker opens up again. And we'd like to go for last call. So comments, suggestions, Rotten Tomatoes are welcome.
Pascal Thibert here, Cisco. Just a point on the wireless piece. It's not that we are not working on it. It's not that we don't want to advertise the work. It's more like it's less mature. So if there was a placeholder for a specific, more experimental work on wireless, I'd be very happy to contribute to that. But it's not at the same level than this document, so it could not belong there. It's pretty much where we are.
Okay, we'll make sure we get that right too. That was Pascal Thibert, of course. He's one of the authors for the architecture, and obviously has a big interest in wireless, being the chair of 6-ish.
Other comments? How many people have read this version of the document? Wow, that's a good number. How many have read other versions, earlier versions? Even about the same, pretty good number. How many believe that the document is ready to go to last call, as in that it's ready to progress? Also a reasonable number, slightly less. What I'd suggest is that we, oh, you did that. That surprised me. What I think is everyone should take a look at the section that's going to be removed, do a sanity check that they don't want to propose any additional text. In the meantime, please do the update you have planned. By the way, the submission opened on Monday, reopened on Monday. So by looking at what the diff is going to be, make sure that there isn't text that you think is important, and we'll move to last call in a short time. We'll give people an opportunity to comment, but even if you don't make the comment before last call starts, you can make your comment about last call during last call. If you do see that, in particular, some of the removed text highlighted an issue you wanted to be addressed, or that you read the document and you see there's something you'd like to see addressed, please not only identify the area you'd like to see filled, but propose text. This is a working group document. Anyone can contribute to it. If you want to see an issue addressed and have a specific idea how to do it, send the text to the list. Thank you.
So our next presentation is going to be from Yoni. So he's doing it remote. So Yoni, if you're there, can you come to the mic?
Yeah, can you hear me?
Oh yeah.
Good.
Oh, we didn't have to push the Meet Echo
We
thing.
don't see you on the Meet Echo interface, but we're happy to hear you.
Do you want to see me?
Doesn't matter.
I'm not so sure.
Ah.
Okay. I should be now visible for everyone, right?
Yep, we see you.
Okay, good. So, yeah, this is my first July in 13 years to actually stay at home, which is a kind of interesting experience. Okay, let's start with the data plane and the what the design team has been working on. So, next slide, please. Next one. There's no change on the design team membership, except that we had the increasing participation from the chair side, but we didn't list them as members of the design team. Anyway, next slide. Okay, so as usual, the working mode has been the weekly calls, and the discussion and the meeting minutes have always been posted on the Detnet design data plane design team mailing list, so you can actually go and check those. Those are available. Just do a search or look into archive. Next one. Right. So continuing a bit slightly from where Norm left off. So the current data plane and document covers a couple of use cases, and this kind of island interconnect where you actually transport a TSN service over Detnet is one of the easy ones, and the one of the main ones what we have defined. So we have the end system that initiate and terminate 802.1 TSN traffic, and we have edge nodes that actually encapsulate that into a Detnet data plane, which in this case is a pseudo wires with MPLS PSN. And on the other end, we decapsulate and feed that traffic back to an 802.1 TSN capable end system. So this is one use case. The next slide. Slightly similar, except that the now the end system are also Detnet aware, so an end system can also initiate and terminate pseudo wires in this case. Otherwise, it's very much the same as the previous one. And then the next slide. And then we have the native IPv6 based Detnet use case. So which basically is that the Detnet end systems they speak IPv6 and they understand everything about the Detnet, so they actually don't use a pseudo wire encapsulation rather than put all the required information into IPv6 header. And this is also one interesting use case. Okay, next slide. And obviously another question comes up that we have two different encapsulations. So what might come up is that we need to think about mixing the use casing. So combining the TSN over Detnet and the like end-to-end pseudo-wire-based native Detnet. That is rather straightforward in a sense that the encapsulation is always the same. However, what we still need to pay a bit more attention to is how to do the interworking function in the edge nodes. And that part is still kind of a bit under the work. And then how about doing the pseudo-wire based and the IPv6 use cases? That we know that we might face it, but we actually haven't spent too much time on kind of working on the details, what that actually entails. So that's one place where more work is needed. Next slide, please. So the solution basics. So we had the pseudo wires and IPv6 as the data plane solutions. As usually and stated multiple times previously, we do not try to invent new stuff. So and hopefully what we design, we can apply also the existing control base with the small tweaks and also the centralized controller model. And especially we want to have that the delta from the existing deployed software and the hardware would be as minimal as possible. That actually kept our invention level quite low. Right, next slide. So the things that we actually spend a lot of time is we were thinking about having a unified encapsulation for all types of traffic, but we didn't kind of succeed in that. So the end result is that the current draft has two encapsulation. One is the native IP6 type of solution, and the other one is the MPLS pseudo wires. The other one that we spend huge amount of time is the flow identification, and we had a multiple proposals during the course of the what we end up with the current draft. So yeah, in a pseudo wire based solution, we have the pseudo wire label that is used for the flow identification. So there is no dedicated Detnet label that we had at some point of time. So we leverage the pseudo wire label for the flow identification. And in IPv6 case, when we don't have pseudo wires, just the native IPv6, we use the flow label for the flow identification. And then it turned out to be surprising. Yep.
We have in queue at the mic.
So, Stuart Bryant, I find it very regrettable that we can't have some more unified way of dealing with both IP and MPLS solutions, particularly as I think to get the best out of this, we're going to have to make changes to the underlay in order to actually extract the most performance. And it'd be kind of nice to only do that once.
It's interesting that you raised that, because part of the reason, from my view as chair, that we moved away from pseudo wire over IP were some of the objections you raised to that.
Well, the point that I raised last time, as I remember, was that you were assuming that there were IP pseudo wires that worked in a particular way, and I just simply pointed out no one had built them like that. What I think we could do is to look at whether we should
disagree on that, because the
Are you just me or Lou or Stuart?
Stuart. So we assumed a certain way of the way of doing the encapsulation, because we knew that there's a support for that. That which doesn't mean it has been deployed, but the actual software and hardware was around.
Sorry, I didn't quite understand
So,
what you said.
so the last time we got some feedback that the way that we designed certain encapsulation is a no-go because no one has done it that way. Well, we had also we knew that there is support for that in the existing systems. No one is just using it. So
Clearly, there's a need for wider and deeper discussion in the working group, given that there will be hardware consequences whatever we do. Designing anything new in V6 will require new hardware, so let's try and understand how we get the best out of the system.
Yeah, there are definitely trade-offs here. I personally am sad to see a single encapsulation for both MPLS and IP. I'm sad to see that go away. But on the other hand, going straight to IP without introducing pseudowires makes stacks the end station implementation a little easier. So I think there's trade-offs here. And I agree completely with Stuart with your comment that the working group really has to consider these. I would say that it's appropriate for them to consider it once this is a working group document and the working group owns the product. Right now, it's just an individual document, so it's the opinion of the authors. So I look forward to it being, one, a working group document, and two, really hashed out by the full membership and all those who may have data planes that will be impacted by this.
I guess we'll have the next round of discussion during working group adoption poll.
I'm sorry, which next round?
We will continue this conversation when you declare it ready for working group adoption.
Right. I would hope that we could adopt the document and have agreement that it's a foundation and then change it as needed.
Well, clearly that's for the rough consensus of the working group.
I just wanted, this is Norm Finn, I wanted to emphasize that a lot of the focus on the data plane documents has been around getting the serial number. The serial is the sequence number, defining an encapsulation to hold a sequence number, which is necessary for the packet replication and elimination feature. It's not necessary for the hard partitioning aspect of Detnet, which is the getting the zero congestion loss and fixed latency. Does not need the serialization and is perhaps a lot more flexible as to what encapsulation you're using. And that may, not all applications need the serialization, so that may have some effect on this too. So relax some of the conflicts.
Yeah, Stuart again. Yeah, I see the serial number thing as being one of the single hardest problems to solve at scale. I mean, you can solve it providing you are prepared to only have a minor number, but I see it would be quite difficult at scale. And also, I suppose one of the serious questions to ask is, how important is that aspect of the design versus having a design that works most of the time for most applications in a simpler way?
I think what I heard, I see both on the slide, and I heard from Norm Stewart, is that those are separable problems. That one piece is the protection part, the serialization. That's the last major bullet. A separable part is the flow identification, and you can solve them independently and then combine them. So it's two building blocks that are combined.
Greg Mreska, ZT. In regard to serialization, so are you envision that the pseudowire is an Ethernet pseudowire? Because saying MPLS pseudowire is a little bit ambiguous. We have very different types of pseudowires.
Yoni, I think that's to you.
So, yeah, currently we assume that what we have on top of the pseudo wires will have the typical Ethernet pseudo wire encapsulation on top of it. And if
Yeah,
we
but,
have a packet pseudo wires, we still have the Ethernet on top of it,
use
and also below it.
control word.
Sorry?
So, Ethernet pseudowire does not use it. Well, again, most of the hardware I'm familiar with does not use sequence number in Ethernet pseudowires.
Well, this one will require it.
And actually, in the Paul's group now, and Stuart can probably will do better job. There is a discussion that many implementations of Ethernet pseudowire don't use control word period. So how you work around it?
Yoni, then Stuart.
Well, we have a certain set of assumptions, and we hold to those. So yes, we do assume that we have a control word, and if the existing hardware doesn't support it, I would say tough luck, because anyway we have certain assumption on top of the existing pseudo wires. So I would imagine that if you want a device, pseudo wire enabled device, to be also a Detnet capable, you just don't find that kind of device off the shelf. So you need to do some update on any of your software or whatever you want to be there. So
That-
so
Then might be
that's the reason why we were like brave enough to take this step.
Greg, another way to look at it is if your hardware doesn't support the protection function, you can't do the protection
No.
function, and you don't need the encapsulation that
Lou,
supports it.
Lou, the point is that they don't use control word period.
So whether you use control word or not, if you're not supporting the protection function, you don't need this serialization ID. And you will need, in order to do, if you're doing new hardware to support a new function, the protection, you might have to support the serialization. So your statement of old hardware doesn't support serialization, it's like, yeah, you're right, but then you're not going to be able to support the new function that we're defining.
But the other thing is that old hardware doesn't necessarily support the kinds of timing performance and basically flow regulation that Detnet needs anyway. So, you know, I'm not convinced that you're going to do Detnet on old hardware. The other thing is, as far as pseudo wire and control word, yes, there's some hardware that doesn't support control word, but we've been talking a great deal about the importance of supporting control word in general, because there are addresses that start with 4 and 6, and without control word, you can't distinguish between Ethernet and IPv4 and v6. So the control word is definitely the way that things should be moving.
Can I set the record straight? So, situation is, there was old hardware that didn't support the control word because it couldn't. We think all new hardware can support the control word. Technically, you can support the serial, the sequence number, but it's optional, and I don't think anyone ever has supported it. So it would be a new for practical purposes, a new implementation that is needed. We are planning to move to a world where we are very strongly encouraging people to put the control word in for a number of reasons, including the ones that Pat referenced.
Okay, and I'm gonna. There's one other point I wanted to make, which is that we have use cases that require the replication and redundancy. That has been part of what is included in Detnet from the beginning, and I don't see how you do that without a serial number. So now, not every use requires that feature, but we certainly have to provide for that feature in what we define in the data plane.
But this is
Name, please.
Norm Finn. This is a tempest in a teapot in a sense. The goal of Detnet is not to support all forms of pseudowires. The goal of Detnet is to do packet rep. One of the techniques defined in Detnet is the packet replication and elimination. For that, we need a serial number, and pseudowires were a handy place to find serial numbers, so we're employing them. The fact that you don't do, some implementations don't do serial numbers simply means, okay, they can't do the packet replication and elimination the way we're defining.
Yeah, and I think Norm brings up a good point is that our objective here is the function. Pseudowires is the way we're using, that is being proposed. If once this is adopted as a working group activity or a working group document, if the worker group decides they want to use a different encapsulation, let's say one that matches what's used in EVPN, for example, that would be a fine choice for the working group, and then we wouldn't be talking about pseudowires anymore. Right? I mean, it looks like a pseudowire, but it's not called a pseudowire in EVPN. That would be a fine direction for the working group to go if that's consensus. Our objective is the function. Our objective is not use of pseudowires.
Just answer. So EVPN, so first of all, the draft is referring 7432, which is incorrect. The EVPN RFC defines multi-point service. So you need to reference the VPWS draft, which is standard track with ISG, which has somewhat different procedures to set up the pseudowire. Number two, and back to control word, in the VPWS draft, the control word is not mandatory. It's optional and mostly used when there's no entropy label. So you might consider to introduce new requirements with regards to EVPN to make control word signal mandatory if used for Detnet.
If we switch to the EVPN
It's not if, it's
encapsulation,
when.
yes, right, we would have to do that.
It's when, it's not if.
That would be another good feedback. If you want to put it during working group adoption, that would be fine. But it's also, even after working group adoption, fine discussion.
Okay,
It's just
our
incorrect.
our minute taker didn't get the name of which draft you said it should be referencing. I'm just, what was the draft?
That's EVPN VPWS. It's with ISG right now. It's almost RFC.
Okay, speaking as AD for both PALs and for here, let's go beyond the control.
Name, please.
Deborah Bringard. Okay, but I'm here as Rowdy Mary AD. So anyway, go beyond control word. Control word for this functionality is a perfectly fine. Let's because PALs is going to have a very strong statement. There's been a lot of problems identified if you don't support for the older equipment, not supporting control word. So going forward, equipment supports control word. So for you guys, definitely for this new functionality, if this is for control word, you have control word to stop that discussion. And as far as I'm seeing a lot of concerns on the design team's work, so I would recommend, rather than waiting too long, bring to the list if you want to adopt the document or not. And if it's not ready for adoption, it can go forward as an individual document, and others are welcome to bring in their individual documents. But I think you're starting to spin your wheels too long in the design team, and it's time to bring it forward.
Okay.
Yeah, I think that's, Deborah brings up a really good point, is we have no other contribution proposing anything for a Detnet data plane. So we have one document as a foundation of the work to the working group. It's individual right now. We're really getting to the point where we're hashing out what the working group thinks is the right answer.
Yeah.
We should be doing that on a working document.
And from the design team point of view, we don't really want to progress this work anymore as a design team. So that's one of the things in the last slide. It's like, okay, we have done our work now. Let's move on the adoption phase and see what whether it actually serves as a basis for the further work.
And I'll say the same thing I've said in other instances. a working group adoption isn't saying that this documented solution is what is going to be the RFC. It's saying this is the starting point for the working group to decide what we're going to the RFC.
Greg Nursky, that actually was what I wanted chairs to clarify, because my understanding that one of the questions that we answer in the working group adoption, that we agreed with the proposed technical solution as a basis for the final solution. So if we think that the pseudowire is not the right technical solution, then what are we saying?
We're saying that this is going to be the place where we document the solution for the working group. If we had alternative documents, we could say, let's pick between them. That would set the direction. We don't have alternatives right now. We have one place to capture thoughts on the data plane. So we have one, if we want to have a working group document in this area, we have one choice.
Stuart again. So first off, do I take that as an open invitation for alternative proposals?
That invitation has been there always. We are always, as every IETF working group is, we are contribution driven.
Okay, that's not always been quite sort of clear. I think the most important thing is that we have open conversation about the contents of the design. I don't think it's necessarily ready for working group adoption for the reasons that Greg just mentioned, but I think we need to have an open discussion rather than continuous closed meetings with reporting.
So just for everyone's information, the design team list archives are available to anyone who would like to peruse them.
That's not
You're also welcome to discuss any document, whether individual or working group, on the mailing list. We had a slide earlier about using the mailing list. If you have a comment, send it to the list.
So in response
Name,
to
please.
Eric Gray, in response to your earlier comment, in most of the working groups, once a design team has been appointed, it's almost worthless effort to try to come up with an alternative draft, because usually people will say, you're not the design team. Why don't you talk to these people? They don't want to see alternative drafts, generally in most work groups.
But there's always an opportunity that if you don't agree with the direction of the design team, that you produce an individual and that gets discussed, and sometimes that even gets either integrated in the final work of the design team, or it gets integrated into the work of the working group. I'm sure both of us have done just that in the past.
Yes, and that is different than what you said. I can't remember a single case in any working group where I've seen an alternative draft, not done by the design team, be adopted instead of the design team.
Oh, I've seen one.
I've seen it before, and I think others will have seen it also.
Pseudowire architectures.
So can we move forward? Oh.
All right. So last comment, and then we still have a bit of time left and some more slides. So there'll be more opportunity for discussion. Please go ahead.
Sharon, the very broad comment. I think if the objection for pseudowire is that the control word is not used, I mean, the RFC 4448 is the pseudowire RFC and it has control word. But now, the issue that who has implemented it and who has not, that's another issue. But the question is, I mean, the objective is minimum change in the standards. So if that standard already exists, we are going to reuse it. I mean, you can implement it again, but we don't need to create a new standard for it.
Thank you. All right, Yoni, back to you.
Okay.
And you have in 25 after.
So how much I have time?
12 minutes.
12 minutes. Okay. All right. So the okay, let's go forward. Next slide. These are just the showing the existing encapsulation. So I don't think I'm going to spend time on too much on those. So this is the MPLS one. So we have the mandatory Detnet control word that sole purpose is carrying the sequence number. And then we have the pseudowire label that is for the flow identification. And then we have a bunch of other labels that we invented funny names. And they just are, I know they are slightly confusing, but just consider them as a normal label stack. You have hop by hop labels, and then you have a service labels and stuff like that. And we do show a couple of uses how to use those. And a better explanation is actually in the IETF 98 presentation showing the some of the uses. Okay, next one.
Okay, 2 questions before you go on.
Okay.
A clarifying question, do you need the control word if you don't care about the protection function?
You don't.
So the control word here is as optional as it is in pseudowires today.
Yeah, but honestly, the less options, the better. So I don't see the harm of saying that you must have it. So
Okay.
So Stuart, actually you get a few other things besides the sequence number with the control word. You get disambiguation with IP, which is pretty important. You get a whole load of OAM, and of course, if you base it on pseudowire, you pick up a whole load of control infrastructure that helps you. So it's really quite a good platform to build, and will save a whole bunch of other work.
So you're in favor of always keeping the control word in all cases?
Absolutely, no
Okay.
question. I mean, I argued from day one, and it was only the presence of legacy hardware that caused us to make it an option.
Good. So we have opinions from the floor that say we have to have control word optional, and we have other people that saying we have to have it. Great.
yeah, the current draft assumes that you have control word always. Doesn't give you options.
I'm
not
trying
having
to
it.
make sure we're capturing the opinions being stated in the room.
Andy Malice. I just, as with my pals co-chair hat on, I just wanted to say that I agree completely with my co-chair here. We're in the midst of making the control word mandatory for Ethernet pseudowires and the pals working group. It should be mandatory for this work as well.
Okay. Next slide.
Yeah, I want to explain why do you need a control word, because your transit nodes that might have doing hashing on a payload need to somehow parse the payload. So if you don't have a control word after pseudowire label, they can parse as something that it is not, and then it will go unpredictably. Okay, so and basically you will have out of order delivery.
So you would be fine with if in the end our solution is we must have control word.
Right, because basically identification of the payload will be done more likely by the first nibble, and if you don't have a control word with the first nibble 0, then it might think of this as IPv4, IPv6, or God knows what, and generate some hash randomly for the same flow. Okay, that's why you need a control word.
Okay. Next slide. And this shows the same thing in an IPv6. So yes, we do overload the flow label, or use actually how it's supposed to be used. And then placing the sequence number, we went for a destination option that that carries the sequence number. And if you go for the next slide, it shows actually the formats. So the the RFC 4448 is used for the as is for the MPLS pseudowires, and IPv6 uses the destination option. And it's pretty much the same as the controller, except that a slightly different format because it being an IPv6 extension here. Okay, next one. Just a bit more about the flow identification. Don't need to go into the details on this, but so there's actually 2 parts into it. So the forwarding and queuing level, and the and the other one is then the using the flow identification for the replication elimination function. Next one. And then the the draft that we came up has a lot of other data plane consideration, and we have a bunch of text about the class of service, quality of service, and cross-Detnet flows resource aggregation. So I'm not going to, for the sake of time, not going to go into details. You can read them from the draft, but it's a bunch of good information. So in that we actually paid some attention thinking about those. And the next one.
Before we move off the slide, I just want to people to keep in mind the data plane implications of the architecture. And when you're reviewing the architecture as part of last call, make sure that all the data plane functions that you're interested in are appropriately captured in the architecture document. For example, the resource aggregation implies some hierarchical control, some hierarchy. Is that appropriately covered in the architecture document?
Jeff, so there's a difference in.
I'm sorry, I didn't hear your name.
Jeff T. So
I'm
there's
sure.
a difference in the way you send traffic over LDP, pseudo-wire, CVP, and in case described here is active backup. If pseudo-wires are set up by EVPN, you could have active scenario, so you could actually provide resiliency as part of the service. I think it's a very important point and has to be captured.
Do you think is that related to the data plane definition or related to my architecture statement? I think that's related to the data plane. Yes?
Greg Mirsky, CT. I'm a little bit confused by their second statement in IPv6 saying it can leverage underlying TSN structure. So my understanding that idea of Detnet is interconnecting TSN domains, not running over TSN.
It does both.
But if you're running both, then why do you need something that, because TSN will give you everything that you need?
So a flat TSN domain is a single Ethernet domain. If you run over Detnet, you have IP partitioning, like you have a router versus a single flat Ethernet. So, sure, we could run PBB and carry your Ethernet and connect your whole world with carrier.
You just plain run IPv6, then IPv6 doesn't need to do if. Basically, if your underlay network provides you all the guarantees, there is nothing to be worried about in a.
Well, then you have the service mapping to worry about because IP doesn't.
Yeah, but
we need to cover that.
Basically, it's benign.
That's fine, but it's something we have to cover.
Okay, so basically, there is a consideration that when we have underlay as a TSN, what if we don't have underlay as TSN?
We have to cover that case also.
For IPv6. Yeah, so I don't see it.
It's laid out pretty clearly, I think, in the architecture document and in the architecture draft and in the data plane draft and the old data plane alternatives draft that one use case is to connect two TSN domains. But that also implies those two domains have layer 2 connectivity. And one of the fundamental limitations on TSN today is the limitations of a bridge network. Even a bridge network that has tunnels between its various parts, bridge network can only get so big, and it just doesn't work anymore. We have to have routers. And so we may have bridge networks at the end and have routers in the middle. Okay, it's conceivable you have routers around a core that's layer 2. Who knows what your architecture is? We have to cover all those cases. That's spelled out in the documents.
Okay. Let's continue.
Hello, this is Alexandru Petrescu. Hello, Uni. With respect to this IPv6 TSN discussion, there is a particular need of connecting a TSN link to a 802.11 link. If these flows could be extended or guaranteed to have a sort of quality of service guaranteed between those two links, TSN and Wi-Fi. Yep.
Yeah, that would be a very interesting document to see in the future how to map Detnet to 802.11. Definitely look forward, if you're interested in contributing in that area, would love to see a draft.
Yes, Pascal alluded to that. The wireless world is somewhat less reliable and robust than the wired world. If you can tell us how to get the guaranteed latency and extremely high reliability in the wireless world, we would love that contribution, and so would the rest of the world.
Why don't we move on?
Yeah.
And
So
as we're actually going to steal a little time for the next slot.
yeah, so we have, yeah. So you can always go and read the stuff what we have from the draft.
Let's hold questions until he finishes his next few slides. And
Okay.
then
So I'm not going to spend anything on this. So just one thing that we haven't really considered at all, or I mean, there is no proper text, is the interworking between the pseudo-wire and IPv6 based encapsulation. So we have a placeholder for it, but we didn't really complete that. So that is pretty much left open how to do that. The next one. Okay, we have a bunch of consideration about time synchronization, a whole section about it. So if you are interested about time synchronization in internet domain, just go and read the section. Next one. Bunch of open issues. So these are the open issues that the design team came up with, what we have. So the as said, the interworking between MPLS and IPv6 domains. The control plane details is actually out of scope of this ID. So, but we did have some consideration to some extent. So, actually, to make sure that we don't design something that we cannot implement with the small deltas to existing control planes. Then one thing that needs a bit more work is the multicast Detnet flows. So the Detnet assumes that the data plane below is basically a point-to-point transport connections. But if you have a multicast Detnet flows, how that should be done, that part needs a bit more thinking and a bit more clarification in its details. The relay and edge node processing for the native IPv6. So originally, because this whole thing was on pseudo-wire based, the existing text is pretty much geared towards how the multi-section pseudo-wires work. So that has to be changed to also take care IPv6, native IPv6 in a proper way. Whether it's going to be in this draft or the other draft, that is a different discussion. Okay, the next slide. So, next steps. So, even if there's still things that seem to stir a lot of discussion and opinions, and whether the choices that we made are appropriate and so on. So the design team thinks that we already did our work a long ago. So we really want to kind of expand the discussion, the rest of the working group in a proper way, and don't want to kind of progress the work in our closed meetings anymore. So one way of going forward is to make a call for adoption as a working group item. Then everybody has their chance to kind of steer the document in the proper direction. So we think this is a good basis. It's far from being complete, but there's plenty of work to do. But the design team thinks that there's at least a solid basis where to kind of go forward. Okay.
Okay, we're going to do something a little different here, maybe a little unusual. Because this has been produced by a design team, number one, and number two, that we don't have any other alternatives. What we'd like to do is, on the list, we're going to call for working group adoption. And as part of that adoption call, we would like to collect issues people see with the document, and that and those issues to be addressed once we have a -00 document. So to use what we're going to do is ask to start with this document as 00, identify issues that people have, reservations people have, and say those issues will be addressed. I'd like to hear now, or we'd like to hear now, if anyone objects to that approach. Please go to the mic. And to be clear, we had one person raise their hand and we have 2 people going to the mic.
Stuart, I think we should follow classic protocol here. We should do an ordinary call for adoption, and you should perhaps for alternatives to appear shortly.
Yes.
Name?
Greg Mirsky, ZT. Okay, so if it's working group adoption, then
on the list. We're not doing it here. We're not.
No, of course, yes. Usually, in some working groups, they do hum whether this document is ready for working group adoption call, and of course, working group adoption call is performed over some time on the mailing list not at the meeting. I agree with Stuart. So it just on the merit of this document, and whatever comments come, the comments come. If there will be alternative documents, then there will be alternative documents.
Deborah Brungard, speaking as your AD. Lou, you can recall, we have more than 10 years experience with design teams. Another approach you could do is, with this document, is make sure to clearly say in different sections that this item, this is a proposal, this item is for further study, and make it clear that it's not, that everything's going to be based on that, for example, using sequence numbers. So that may, allow others then to input, and then you can merge in later other proposals. But make sure it's very clear that that item is still for further study.
Yeah, we certainly have followed in multiple drafts when there's multiple proposals to put them in the same draft and identify that it's under contention. And that would be a fine way to deal with how we capture the issues in a -01 version. So we would publish a 00 and immediately go to a 01 that identifies the issues in the draft. And that sounds like a good way to capture those issues that are part of adoption. So I like that idea.
Stuart again. So it's not, of course, just sequence numbers that I'm worried about. So
I think that was an example.
Yeah.
I don't think that was.
The problem that I have with this approach is that accepting a document as a working document usually implies a high level of endorsement on this particular technical solution, and there are areas in there that I am worried about, and I don't think we've debated properly as a working group.
Yeah, so Deborah does point out, like, for example, there was, I don't know if she's thinking of a particular CCAMP document I'm thinking of, where right after adoption, we put in every section of, here are the different approaches, or this is not settled. And it was in this, if you went and pulled the latest version of the working group document, you immediately saw that it was an area of contention. So I think Deborah is proposing that we do that as part of the working group adoption process. And I think that's a good way, because then whoever reads it anywhere will see that it's an open issue.
So Eric Gray again. I agree with Stuart completely. The reason why I object to that change in the procedure is that we can almost as easily put the 00 in with that information in it. And by putting in the 00 without addressing the fact that there were issues that have been raised in this room, as well as issues that could easily come up between now and adoption that have to be addressed, you still give the people that haven't been here in this room and who are only paying attention to what's getting posted, you give them the impression that this is the direction we're going.
So that is actually a bit of a change of a norm, where normally the 00 is identical to the last individual. Eric, stay there because I want to ask you, make sure I understand your proposal. You're proposing that the 00 have in it any issues raised during adoption introduced in the text. Is that correct?
No, what I'm saying is that you respin the individual with those issues in it, and then you post it as a 00.
How do we know the issues until we do adoption?
You have a question. Stuart, you could clearly ask that question first.
Okay,
Right.
consider that question asked. I think we've asked it multiple times. If you have comments on the document, send them.
Greg Mirsky. So I think that, Lou, I like this, your proposal, is that let's first call for comments on the current version, collect the comments, identify the comments that working group agrees need to be incorporated before the adoption, and then do adoption call.
We'll do that, but we'll call it a two-stage adoption process.
I think we're saying almost the same thing. I mean, I've seen a lot of, on the MPLS mailing list, for example, where we've had a lot of objections to the exact wording in the draft being proposed for adoption, where the working group chair has said, after these things have been addressed or at least identified in the draft, then we will post it as a working group document.
And certainly that's a pretty normal thing, is identifying issues and addressing those issues. The point is, we're not going to address them this time. We're just going to document them this time. And that's fine. We'll do it as a two-stage step. First, we'll collect the issues, get them into the document, and then move that version into a 00. Okay, sounds reasonable. Yoni, anything to add before we finally kick you off the screen?
Well, I don't think so.
Thank you for doing the presentation remote. I think it worked out pretty well. With that, we're going to move on to Velazquez. If you could give back 5 minutes or more, so if you could aim for 15, that would be great. Thanks.
Okay, so my name is Balazs Varga, and this presentation is about Detnet.
You're not amplified. You need to get.
Okay. Is it not that? Oh, fantastic. Okay, so my name is Balazs Varga, and this presentation is about the Detnet flow information model update. And I will speak in the name of the artworks you can see on this slide. But you will see here, I will give a status about the draft. I will also highlight what updates we have made since the last version. And there is also a slide about proposed next steps. There were two drafts about flow information model. This is what we have identified in the last Chicago meeting. And since then, there were several discussions in order to merge these two drafts to a single proposal as being the flow information model. So this is what you can see and what we have updated. This is exactly the result of merging these two drafts. Of course, we have also updated according to the data plane encapsulation defined recently, and this is what you have discussed in the previous presentation pretty well. And there were also updates regarding the Detnet domain related flow information elements. In the previous version, it was very much focused on the flow and the edge nodes, and now there are also attributes regarding the relay and the transit nodes. And there were also updates regarding possible traffic specification extensions in the draft. So regarding the data plane design results, we have updated section 6.1, which is dealing with the identification and specification of flows. We have defined two identification attributes group, which can be used at the UNI for a layer 3 or for a layer 2 flow. And in addition, we have also defined attributes in order to identify the flow inside the Detnet domain. And this is what was done according to the data plane encapsulation specified. We have also added some text to the traffic specification. So the current definitions allow practically any type of traffic to be described, but it is always describing the worst case scenario. So each of the flows will be treated as a CBR flow and reserve resources according to that. During the discussion, we have identified the need to define some VBR specific attributes. We think that VBR attributes can be used only for flows which have limited requirements. It means that they are only loss sensitive or they are only delay sensitive, but not both loss and delay sensitive at the same time. Here we have highlighted in the document as notes 3 possible options how to deal with VBR traffic. One is to define average attributes. Another method is going according to RFC 6003 and speaking about bandwidth profile, committed and access rates. And there is also a possible option to have application-based models. This is something, for example, used in 3GPP. We have also updated section 6.3, which is about the flow rank. This is about which flows are important if you have lack of resources in your network, how to decide which flow you would prefer. There is a new section added to the document, which is dealing with the Detnet domain. This is practically where your Detnet flows are encapsulated according to the Detnet domain forwarding methodology. So this object is specifying the behavior of the Detnet domain, how the flow is encapsulated, what are the requirements to forward the flows, and what are the capabilities of the Detnet domain. So in order to do that, we had to define Detnet domain capabilities. Here we have defined 2 attributes. One is related to the encapsulation format. The other is related to the replication and elimination capabilities of the domain. We think that there are still additional attributes to be defined here. So here we see some further work. And we have also added some notes in the document because defining the Detnet domain, it can lead us towards also define node-specific attributes which will be needed for configuration of those nodes in order to set up end-to-end flows in the Detnet domain. And practically that's it. So we have added Detnet domain-specific extensions. We think that there are some further work on that. We think also that on the format of the attributes like traffic specification, this is also something where we need some further work. However, we think that with the merge of these 2 flow information model draft, we are quite stable regarding having a baseline for the flow information model draft. So this is why we are calling for the adoption on that draft.
Comments? Before we go to adoption, we have some additional perspectives from Mock. So I'd like to come back and talk about adoption of the document. But first, Mock's going to talk. Before we move on, though, how many have read this document? Can you raise your hands high? So that's just a few.
Good morning, everyone. This is Mark Chen. This presentation discuss some consideration on Detnet information model. So the motivation for this presentation is that we think the current information may not include enough information that can be used to support how to establish Detnet flow. So after discussion with the information model author, we were encouraged to present this some consideration about this information model and try to select feedback from the working group how to progress relevant works and maybe what information should be should be added in the current information model, or should be documented in separate document. So here's the current charter of about the information model. So my takeaway about this charter is that the purpose of the information model is to identify the information that can be used by the control plan or the YAML configure-based solution to establish or control the data flow. And also the information should be independent from which protocols to be used for the establishment. So based on the current charter, here is a thought about the information should be, what information should be included in this, should be included. So here's from the procedure of how to establish a data flow point of view. So you can say that if you want to set up a data flow, the first one is to get the requirement of data, for example, the flow identification and the flow constraint information. And also we also need the Detnet, the network information, and combine the both information. We can an entity can compute the path, and the Detnet flow path information can be used to direct how to, for example, if you use that lemma plus conf to configure the path, the information can be a base to direct how to define the YAML model. Also, if we use the control plane protocol to establish data flow dynamically, and that information can be the parameters input to the control plane protocol. So once the data flow path established, there will be relevant flow status that can be collected by, for example, by the ingress or by the controller to monitor whether the path is ready or not. So you can see that in this picture, the red box, the information in the red box is covered in the current information model, and the blue one is the information that we think should be belong to the information model and should be added to the information model. So here's some details about the flow constraint information, which include the flow identification, for example, the source or destination address and the flow requirement, what the latency, redundant number path numbers, and also the traffic specification, which is, for example, the interval, the packet transmit interval, and what's the maximum packet size. The figure on the right side shows how this information can be used when to start to establish a data flow path. For example, this is a centralized model where the application controller may send the flow constraint information to the level controller, and level controller can use information and combine with this one, combine with network information to compute the path. This is shows what kind of network related information should be maybe used to support the established computation and the establishment. Which we categorize this information to three categories. The first one is domain-wide information. This is not dedicated for a single device or node. It's applied to the whole domain. For example, there may be encapsulation attribute that can be used for a specific domain, and the priority that is allocated to Detnet flow, and also they also need the network topology, and this one maybe has already defined by other working group, for example, the IETF or another TS working group that are working on relevant YAML models. But beside that, there also needs some Detnet dedicated capability information, for example, the the maximum load latency, and how many reservable bandwidths can be used for the Detnet establishment. We can see that this information can be collected by the network controller and combined with the flow control information, we can compute the path. Yeah, this is some details about the flow path information, which include the flow identifications, flow route, and the path attribute. This information, I think, is necessary for how can be used for example, the a model-based solution to configure the path, or can be used as parameters to the control plane protocol to establish the flow path. Here is the flow stages. As I said before, the red one is already covered in the current model draft, and the below there may be, for Detnet flow, it's not just like the normal flow. There may be relevant, there may be special loads for flow paths. For example, the replication and elimination node. They also have some status in that load. So we also need to collect the relevant status in those nodes. Then we can use all the status to reflect whether a data class can be used to transmit the packet. Yeah, that's some consideration about the models. So here's actually some questions about how to to progress the work. As a side that the work on the flow information model is going on, but there's no details on network configuring part so far. For example, for the input part, the network topology, load capabilities, and some other information is not covered in the current information model. And also the output part, the flow path information and load configuration information is also not included in the current model. And yeah, here's some our question to the working group, how to address this configuration part. So within this information model draft, or to document in separate draft. And also there's some question how to leverage the relevant work that has already been done in other working groups. For example, the topology models, TESP models, and control plane relevant stuff.
Greg Mirsky, ZT. It may be not relevant, but you list as an input node capabilities. There might be an interesting problem that if we use node scope performance metrics, trying to derive or define the constraints for their end-to-end flow. So the question is, what metrics we need? Do we use maximum values, or we use some other, and how they obtained? So that's the whole different universe.
Yeah, in my personal opinion, I think that the maximum low latency should be used, because for Detnet is trying to guarantee the worst case. So the maximum latency should be used, considered. Yeah.
Right. The question is, so how their latency being measured on a node, because the methodology of the measurement would be important. But I think that's some different discussion.
Yeah, that's right.
Dejan Bogdanovic. So how you created sets of your models and the information model, how you group them, I think that's a really good way to proceed with the building information model. And I would even encourage you to build the initial structure that should stay the same as much as possible throughout the the life cycle of a draft. Because if you go, like, for example, let's say on the, just on the, one more, please, that one, for example. So here you already said, okay, for the flow constraint information is I need to have, flow identification, flow requirements, traffic specification. And with that, you're saying, okay, this gives me description of my flow constraint information. Now, if you leave that, I wouldn't worry at the beginning which all attributes and parameters have to go in there. It's just, that as an initial abstraction is valuable for the modeling, and then keep that as a structure, and we can then expand it down the line when we are finding out which other information pieces have to go in there. But this is the one part that we should agree early on. Is this all that is needed, for example, for the flow constraint information, or is there other major grouping that has to be put into the structure?
The nice thing is this structure lines up with the way IETF has been doing this for 15, 20 some years.
Yeah.
So this is the pretty normal way that IETF has been doing it. So those 3 blocks. I mean, they've had slightly different names, but it's the exact 3 blocks.
Carl Weber, Back of Automation. I'm wondering what you mean with central user configuration and central network configuration in this context. We are talking about the internet. Do you mean one central instance for the whole world, or for a very local site? And if you have overlapped Detnet domains, how to handle this in this context? So I was a little bit surprised about this terms and how to do it.
Yeah, actually, this picture is not drawn by myself. I just borrowed it from the TSN material. There had already defined, a centralized model and also dynamic distributed model. So here, just use this model to explain how to use relevant information.
Janos Farkas, maybe I can try to answer. So we are talking about a single administrative domain, not the big I internet here. That's why. So these controllers are for one domain.
We're also not covering control yet in this working group. So this is sort of just a reference model to keep in mind of how it might be used. It's not how it is going to be used. It's a possibility just as an exemplar. It's an example. It's not a requirement. It's not what we're saying must be done or will be done. It's just an example.
So then it's stated in the document that this is whether you do it in a centralized way or on a local base or so on is completely out of scope.
That's in the architecture. It's also in our chart. It's also in our charter that we're not doing the control plane.
And I just wonder why you mention it there, because it's completely independent from the parameters on the left-hand side. So why you use it on the right-hand side?
If you go to the last slide, I had a question about leveraging work. So you would directly map into T service selection work in TS. So we just need to include your use case and work with it.
Yes.
You might think about whether you want to be mapped into something like L2SM and then into PSN, or request directly to null with particular characteristics. And probably you are not interested in the semantics. You need an abstracted view of two endpoints.
Yeah, yes, I think that is allowing is what I think. But we need also can based on that existing work and do some necessary augmentation to to satisfy the Detnet requirement.
Absolutely.
Yeah, we're running out of time. Actually, we're a little over. So I'd like to try to wrap this up if it's okay. What are you suggesting that these issues that you've raised be addressed in the individual draft, or are you saying it's okay to start with that individual draft as a working group draft, but you'd like to see these types of matters addressed by the working group? Which one?
Yeah, we're open. We're open either way.
Okay. With that, I'd like to move to asking about the prior draft, the flow information model -01. If we saw that just a few people had read it, I'd like, clearly we're not going to adopt today, but we can get an impression of whether people think it's ready, or do we want to see it mature a little bit more, perhaps with some of the issues that Mark has addressed in the individual. So how many would like to see the -01 document presented by Lazis accepted as a working group document now? So how many would like to adopt? So it's about the same number as red, so I'd say that a few. How many would like to see it mature more, perhaps address some of the issues that Mark has raised before adoption? I'd say it's about the same number. Okay, I was hoping for a little stronger indication one way or the other. We'll talk with the chairs, maybe our AD, and think about a way to go forward.
Janos Farkas, just a question for clarification on the next step. Like, there are a number of questions, and what should go in a different draft or this existing draft? So should we continue that discussion on the list before, or what's the way forward?
I think it would be great to have discussion on the list, so don't wait for the chairs to do anything. We're going to have to talk because there wasn't a strong indication of anything here. There was some feelings. Given that this has been out there a while, my inclination is to go forward with a poll, and if it fails, it fails. But then we know. But I want to talk with my co-chair and the AD as well before that. But in the interim, don't wait for us. If you guys can get together and figure out how to make, you have some text, hopefully you have some text behind these ideas. If you have some text, you can bring it in, and maybe we can get a new version by the time the chairs get around to taking action.
Yeah, sure.
Yeah, as always, we're text driven here. So if you have ideas, propose text to fix it, to address those ideas. Thank you very much.
Okay, thank you.
Hold on one moment.
My name is Tal Mizrahi. I'm from Marvell, and we're going to talk about Detnet security considerations. So this draft is a collaboration of, it's not a design team, but it's a team of people who design or designing a document. So Ethan Grossman kind of shepherds the flock, so to speak, and the rest of us also include Andrew, Sabir, John, Henrik, Kevin, and Norm. Okay, so this is basically the outline of the draft. As you can see, we've made some significant progress in the last few months. Actually, in the current revision of the draft, there's quite a bit of new text. And the draft mainly consists of security threats, which means how an attacker can attack a Detnet system. Impact, which means what happens if there's a successful attack. Mitigations, which means how can we try to mitigate or solve some of these problems or attacks. And finally, there's some discussion about use cases. So now we're going to talk a bit about each of these different sections. We'll start with security threats. So in a nutshell, the threat model distinguishes between internal and external attackers. An external attacker is an attacker who is not within the premises of the trusted zone in the network. An internal attacker either has physical access to the trusted zone of the network, or if there's a cryptographic protocol which is in use in the system, an internal attacker can also be someone who is outside the trusted zone but has access to the cryptographic keys. So that's the distinction on the left between internal and external. On the right, we see a distinction between on-path and off-path attackers. So an on-path attacker who is on the path between the source and the destination is also called a man in the middle, is someone who can intercept packets. And an attacker who is not on the path, an off-path attacker, is also called an injector because they can basically inject packets. So this is the threat model in a nutshell. And since we love ASCII arts tables, there's a lot of them in the draft. So this is an ASCII table that basically summarizes the attacks, and for each attack, it tells us which attacker types are relevant to that attack. More details in the draft. So we talked about the threats. Let's talk a bit about the impact. What happens if an attack is implemented successfully? And in terms of the impact, we distinguish between what happens, what is the impact of a successful attack on the control plane, and what's the impact of an attack on the data plane. So first of all, let's talk about recon attacks. So for example, if there's a recon attack on the control plane, that means the attacker can monitor any changes that happen in the network. And for example, they can know which flows exist, what their flow IDs are. If there's a successful recon attack on the data plane, that means the attacker can track the activity of the Detnet flows. Also, they can try to find the right opportunity to use other attacks to attack the system. Let's talk a bit about how the impact of delay attacks. So first of all, a delay attack on the control plane, that is, if you delay a control plane message, for example, a control plane message that is supposed to add a new Detnet flow or to remove an old Detnet flow, the impact of that may be, basically the impact is that you mess with the resource allocation in the system. So that means you can either reduce the quality of service or you can cause resource exhaustion in some cases. Now, a delay attack of data plane messages, so obviously these messages are delayed, that's already a bad impact. It also causes packets to be buffered in some of the bridges and routers, which may cause congestion. So it has other implications as well. Other types of attacks which may be considered, modification or spoofing attacks. So first of all, in terms of the control plane, obviously, any control plane message that can be used to create, remove, or modify these. Once these messages are compromised, that means the attacker can perform these operations. On the data plane, if the attackers perform a modification or spoofing attack, that means basically they can use resources of the network that were not intended for them. Okay, so that's basically the impact of that in terms of the data plane. Now, generally speaking, at this point, I should say that when we talk about attacks and impact, in the context of this document, we're not talking about generic security attacks in general. We're talking specifically about attacks that are relevant to Detnet environments. And we're focusing on those. And so if we're talking about the impact, if I have to summarize in one sentence what's the impact of a successful attack on a Detnet network, basically it means that Detnet flows are forwarded in a non-deterministic way. Okay, that's, in a nutshell, that's the impact. So we talked about threats, we talked about impacts. Let's talk a bit about some of the mitigations we can use. So obviously path redundancy is kind of built into the Detnet architecture. It can help mitigate various man-in-the-middle attacks. If we use integrity protection or authentication methods, it can help to mitigate spoofing, modification attacks. Now, encryption, we're not really interested in confidentiality in the context of Detnet. Okay, it may be used for other purposes, but specifically for Detnet, if we were using encryption, it can help mitigate some recon attacks. Okay, so that's the benefit of encryption. Also, obviously, if we want to mitigate control plane attacks, we want to protect control plane messages, either by integrity protection or encryption. And in order to try to mitigate resource exhaustion attacks, if we have performance monitoring and analytics, that can certainly be a useful tool for that. And another ASCII table, basically we summarize all the attacks and map them to the corresponding impacts and mitigations. Okay, more details in the draft, of course. So another aspect that was added to the current version of the draft is use cases. So based on the use case draft, we basically have here a list of use case themes. Each theme is kind of a property or a feature that may or may not be used in the Detnet environment. And so for each of these themes, we analyze what are the security considerations that are relevant specifically for this theme. So there's a discussion about that. And again, there's a summary which kind of maps each theme to the attacks that are relevant specifically to that theme. Okay, so to summarize, we presented this draft for the first time in Chicago. We received good feedback. There was wide support. We've made significant progress since then, a lot of new text. We believe that at this point, the draft is ready for working group adoption. And we'd like to ask the chairs to call for working group adoption. Any other comments will be welcome. Thanks.
Comments? How many think that it is worthwhile to have a document covering security considerations? Don't even finish the sentence. How many think it's worthwhile having this type of document? A reasonable number. How many have read this document? A little less. How many would like to see this document as the foundation for the working group's activity in this area? I would say more than have read the document. So I think that's interesting. I appreciate that. We will take it to the list. Thank you.
Thanks.
Just one small sentence for the author.
Please identify yourself.
You want to be very realistic when you say what's the damage if a deterministic network, if the deterministic flow is broken, is stacked. It's not deterministic. That's not the consequence. Those deterministic networks are meant to be used to interface with the real world, as opposed to many of the networks we've built so far. This is really talking about doing things in the real world. And so if this deterministic flow does not go through some physical systems, some machines will break, some people will die. So that's what the consequence is. It's not just a flow that goes non-deterministic. So when you look at about what measures do you put in front of that, it's not, oh, I'll put a firewall tomorrow and I'll fix it. Right? This kind of countermeasure has to be something which works in the next seconds or the next minutes.
Good comment. And when you're reviewing the document as part of the last adoption call, if you identify a shortcoming and have an idea of some specific text you think could be added to address it, that's your specific comment, or this applies to anyone in the working group, please include that as part of your response. It could be, yeah, we should adopt it, and here's some text I'd like to see added in the working group document. Thanks for the comment.
Hi, I'm János Farkas from Ericsson Research, Hungary. And with my colleagues, Balázs and István, we have implemented the packet replication and elimination function in a software switch. And this is an implementation report of that implementation. Actually, that is along the, as described in the data plane solution draft, the current one, the 0.1. So this, out of the four key features we need for deterministic packet networks that we are working on here in Detnet, this focuses on the reliability, the packet replication and elimination function, in order to achieve or provide extremely low loss. In other words, avoid the equipment failure. So this the mechanism itself has been specified by the 802.1 CB document, which is called Frame Replication and Elimination for Reliability, the FRER. That includes pseudocode as well. Actually, we used that code in our implementation. Also specifies the layer 2 data plane aspects. The data plane solution draft 0.1 calls it packet replication and elimination function, and provides the details of the layer 3 data plane, which we have discussed before along Yuni's presentation. So this, what we focused on is the pseudowire over MPLS. The basic idea, I think you are all familiar with, that this is a per packet redundancy. We have a replication point that replicates the packets, adds the sequence number, and sends the packets on disjoint paths to the elimination point that gets rid of the extras and sends on the one copy. So that's the basic mechanism. And so what we did is that we implemented the feature on software switches in a ring topology, as illustrated in the figure. The lilac ones are the replication and elimination points actually implementing the feature. The gray ones just simple software switches. And the use case we have been checking it with is a balancing robot on one side, and the balancing logic is moved to the cloud. It's a remote logic, and that goes to the network. We compared the replication function with the classic 50 millisecond protection switching, for which there are a number of mechanisms already today. This is the use case we have been focusing on, the TSN service over the Detnet network, as described in the data plane solution draft. So what we have on the wire is that, so here it's a layer 2 encapsulation with VLAN ID, and the replication node, or the edge node, actually is the one that adds the MPLS T label, the pseudowire label for the flow identification, and the control word is the one that carries the sequence number for the replication, as you already heard about a couple of minutes ago. This is just a screen capture Wireshark if you want to check offline what we have on the wire. And we evaluated two use cases. First one is a simple link failure. The protection switching mechanism provides a 50 millisecond failover. So in other words, it is a 50 millisecond outage for the application. And actually, the replication function works a lot better. So if taking a look on what happens when we have protection switching only, we are cutting the link, this link here from software, from a shell, actually, to make it easy, cutting it for 50 milliseconds, as you see up there. We are losing three packets indicated here for the control application, which makes the balancing robot falling over. So the control is lost. And if we turn on the frame application and elimination or packet replication, then we can cut the link for whatever long. The control is surviving and the balancing works just fine. The other scenario we checked is the link flapping, which is like if it is, for example, 20 milliseconds downtime, then your monitoring for the protection switching often doesn't even detect it, but it still affects the application. So if there are these outages, then the balancing is over, and if with protection switching. But if we turn on the replication and elimination, then the balancing logic is up and running fine. So as we experienced, the packet replication and elimination function actually provides really hitless failover. There's no switchover in the mechanism as designed. And we implemented it as described in the data plane solution, so it just works fine. There is a demo of it this afternoon, in the first afternoon coffee break, 3:30 in the Tirolka room.
Just clarifying question. Did you implement, never mind, it's on the slide.
Any questions?
Pascal Tuber again. We did a very similar demo on 6-dish with a stick of wood that holds. And the point I want to make about this is we had this information model earlier, and it seemed to reflect the classical thinking of so many nines and this sort of thing. And those control groups don't care about so many nines because they can miss a packet once in a while. Even 10-3 would work fine. What breaks the system is a number of packets that are lost in a row. So that's really the sort of metric we want to capture, to which we are not so used at the IETF, but are so critical for industrial process.
Yeah, for many control applications.
Jeff, for clarification, you've shown single link into PSN. Is there really one link or two receiving bus flows?
So when the replication and elimination is on, then it goes on both links. So that's
before the P router. You show single link between controller and
for this simple demo, it's a single link. Yes. So here, as it is shown, this is just a single link for this demo. Yes, that's a single point of failure. If you go real life, you need to do some dual homing or something, or you can move the replication point to the application. That's another way to solve. Actually, this is why here in this illustration, it is a bit vague where this application and elimination points are, because they can be anywhere. They can be in the application, that can be an edge node, that can be core nodes. You can have fancy topologies like ladder, and there are many options for that.
And the definition of how many packets you're allowed to lose before you start accepting packet from the second flow is done manually.
So based on the sequence number, only one copy is forwarded of each packet, and all the extras are dropped.
You discard them at egress, right?
The elimination point discards that. So if it is the edge nodes that do the replication elimination, then the egress edge discard.
It's sort of think classic protection domains.
Yeah, we did it in PIM faster route many years ago.
Yeah, it's also we've done it in lots of places, but it's a classic protection domain with 1+1 protection, and they're doing hitless. So there's the number you lose before you switch is 0. So on the first loss you switch, and it's on a packet by packet basis. So every packet you can switch back and forth.
And the amount of state created is not worrisome. You do it per flow, right? Per pseudo wire.
It's per flow, yes. So you have to keep track of the sequence numbers, and yeah.
And that's exactly why I was talking about the ability to do hierarchy.
Yeah,
exactly.
Thank you.
Kiran Huawei, a quick clarification. Do you run into any issues where sequence numbers could be out of order at the end too? So then you assume that you lost a packet?
Well, there are a number of sub cases and issues you have to take care. There's a window you keep tracking the sequence numbers. There can be the delay can be different on the two paths, so you have to buffer. So this is just a basic, simplest case, but all of these are covered in the specification actually, or addressed.
Yeah, it's good to have, whenever we're doing something new on the data plane, it's good to have some validation of it. So this is useful information. Again, this was on the individual draft. We would hope that other implementation, experimentation could happen as the working group draft evolves, or as we have a working group draft.
Carl Weber, do you also, if you have a very long path and a very short path, then it could happen that the frame order, that you receive frames out of order. Do you have covered this as well, or is this out of scope of your project?
Yes, we know it. It's your choice. I mean, whether in the bridges or in the network or the nodes you want to keep the order, or is it fine for the application to have some out of order somewhere you need to buffer if the
Yeah, we have a document in 802, IEEE 802.1 CB, which is in the process of being going through the mill to be finalized and published. It's going through the publishing mill. I can get you access to that. Talk to me. It covers a lot of these questions. It's been explored quite a bit, and all of these are valid questions, and some of them have easy answers and some of them have hard answers, i.e. expensive.
Please use the mic or have a side conversation if that's what
The
you want to
question
have.
was, can I share that on the list? And the answer is, not exactly.
I think you can share the URL, but not the passwords, right?
Correct.
So why don't you at least share the URL?
It certainly will.
Because lots of us have seen the same password that's been used for the last 30 years, something like that. Shh. Sorry, I didn't say that.
Yeah, maybe we can go to the next topic.
Moving on. I didn't say the password.
Okay, so the next deck is a bit of an overview of TSN, what we are doing in 802.1 TSN as an input to the work going on here in the Detnet working group. This is based on the tutorial we gave Sunday on TSN with Norm and Pat. So I need to say here as well that this is not an official view of IEEE 802 or 802.1. This is just an individual view of the presenters. Dictionary, this slide deck, since it's about TSN, uses the TSN terms like stream instead of which is so for Detnet, and talker, which is a source, and listener, which is a destination. So this deck includes, after some introduction, how do we describe a TSN stream, what type of techniques we use, QS techniques, per stream techniques or per class techniques, to achieve zero congestion loss, what shaping and time scheduling. And there will be there are some slides on frame preemption, the transmission preemption, and then the end there are some discussion items brought to the floor. Norm, you wanted to talk about these slides, if you.
Brief reminder for those who aren't sure why they're in the room. This is, Detnet is all about a not to exceed end-to-end latency. It's not about average latency. Average latency is irrelevant. There are lots of ways to accomplish bounded latency. A way we are choosing is not to throw away the packets that are late. That does the applications, that does Janos's application no good. The robot falls over. We're after providing zero congestion loss. Now, there is no free lunch. The low-hanging fruit in this space has long since been eaten. We're taking approaches to explore the remaining space in trade-off space. The axes of our trade-off space include when we have a number of different techniques that we're doing in 802. Number of different queuing techniques to make this real. We wind up trading off what sort of latency do we get? How low is the bounded latency? What's the magnitude of this bounded latency? How complex is it, i.e. expensive is it to implement this? Can we serve a wide range of applications in the same network with different requirements for how much bandwidth they need? What is the latency? What is the variation in the latency of the delivered frame? How difficult is it to deliver the packet exactly on time? Forgive me if I use the word frame. That's what we call it in 802. And the ability to handle dynamic reservation changes. That's also not trivial. We can't necessarily stop everything in order to add or delete or move a reservation. So we're taking two fundamentally different approaches, and one is per stream traffic shaping. That's one that's fairly familiar to IETF people, and the other is time-based transmissions, which may or may not be relevant. But one thing to stress is that we're not talking about observing the traffic and deciding what we need to do to help it out. Everything is done with an a priori resource reservation. You don't get the service until you've asked for it and the network has prepared itself to handle your flow. This is an example of how in a network, a relay node, you can get this QoS and reliability functions. It is a hierarchy. You'll notice there's nothing in this diagram about selecting which port to forward it on. That's the routing function, the bridging function, the forwarding function. That's not our business. We're talking about QoS. We do per stream filtering and policing. We do the packet replication and the elimination, and we do per stream shaping, and we do per class queuing in this model.
Norm, before you go on, actually this is as contributor, but I won't make it to the mic in time, so I'll use this mic. It's Lou Berger. You show here that you're doing shaping after replication. Does that mean you go into two shapers, or n shapers? Because
that's not required. This schematic is not perfectly accurate.
Okay, so it's sort of a logical representation. So
it's listing the functions, not necessarily in that order.
Okay. All right.
Okay. Thanks. That's the voice of experience, which many of us have. Do you queue it? Do you shape it before or after you replicate the multicast? We have to identify. Tell me when it's your turn. I'm sorry. Am I gone past? I apologize.
Either of us can talk about this. So this section is about how do we describe a stream or a flow in TSN. A key aspect is the identification. So for that, there are multiple options in our documents. It is the document is not listed, sorry for that. The QCC document and the CB document, those are the two that describe. So the MAC addresses, obviously, and VLAN ID, as well as the priority code point, the layer 2 priority field, and we also have the possibility for DSCP and IPv4 5-tuple, IPv6 5-tuple. It is important that all these flow identification is only for QoS purposes and potentially for encapsulation transformations at the edge, and they are not for forwarding decisions. So not for the forwarding discipline. The next two slides explain the next two aspects, the traffic specification itself that goes to the user network interface and the network's reply to the request. So the traffic specification, it is a request from the host or the talker, as well as its promise that this is the traffic that will be provided to the network, and the talker is not supposed to violate it. So we have a packet interval. This is for CBR traffic. We have a packet interval, max frame size per interval, and the max frame size. This type of specification is observable and verifiable. So this is good for you and I. It also includes or may include the talker behavior. So the talker, the host, may implement one of the shaper algorithms itself that can be then programmed by a central controller, like, for example, the time-based queuing we have. And the talker itself can be time-aware, and offsets, early or late offsets, can be programmed for the talker if you want to have offsetting, apply offsetting to your traffic. The talker also expresses the application's needs, which is a kind of requirement towards the network, the worst case end-to-end latency, and the other one is the number of disjoint paths needed for the frame replication and elimination. So these are the requirements from the user or the host to the network. The network responds both to the talker and listener with a status info, which can be empty, it can be none, or it can just be ready, everything is fine, or it can say that it's failed, something is wrong, and there are failure codes specified on how to be able to figure out what went wrong. In the response, that includes as well an accumulated latency, which is a worst case latency for one frame.
If this response is sent to the listener, to the destination, then it is about a single path. So from the source to the destination, this is the worst case latency. When the network sends this response to the talker, to the source of the stream, then it is about the worst paths among all the listeners. So the worst case latency for the longest or worst path.
Pascal Hubert. Hello, Janos. I think we are used to the concept that this is for constant bit rate.
Yes.
And an application may be very clear that it's going to throw constant bit rate. But at some point, there is the transport and the network which may decide to put those constant bits into one or more packets. And the way it's described, being number of frames and maximum size of frames, makes it so that if I send 2 frames of 500 bytes, it's not the same thing as sending 1 frame of 1 kbyte. At some point, the shaper will react differently to those 2 constant bit rates. I was just wondering if that means that we should tell something to transport, have some specific transport with particular limitations or particular angles. Oh, I'm doing Detnet, my transport should definitely not be TCP with MSS being whatever it is. And, or if there's a need for something to block the packet and reconstitute deterministic friendly blocks that can be transported according to this contract.
So in the UNI, it is for the application. It's the application's decision how many packets in one period.
Yeah. So I think Pascal, you're raising a really interesting question or point. Is that it might be beneficial for the Detnet layer to provide the transport protocol information on what service is available. If I understood, that's what you're saying. Use the mic just so the remote people can hear.
I was in the problem space, not in the solution space, but I agree that you provide an approach to solving what I'm saying. I was just saying, okay, the application sees CBR, but there are things between the application and Detnet which may turn that into not a constant number of frames, depending on how the frames are being built based on what the application outputs.
We actually don't have a way right now for Detnet to expose any information to the transport protocol or the application.
Right.
So that's an IETF problem, and beyond the scope of Detnet, but one that we should be talking about here so that we can start figuring out who we talk to. So we could look to RAD for help, but saying maybe we should start figuring out someone from the transport area that we can start talking to about opening this dialogue. It's not something we're going to solve here, but in terms of the actual users of the technology, they need this solved. So it's a good IETF problem to bring up.
Yeah.
So this, by the way, this is exactly sort of the reason to have this talk here is this, by going through these 802.1 TSN pieces, it can inform our discussions here and our process here. So thanks.
Yes, I wanted to also say that it's a very good discussion item on what to do in Detnet, and this is just an input for discussion. So far, this slide is only TSN, and it would be nice to have all these discussion items collected. So we have some at the end, but it would be good to have added or somehow collect these items. But this side is only TSN as an input to what do we do in Detnet.
My question to you was just if you think about solving it at the lower layer or expect the upper layers to do it. Because you could do blocking just like Wi-Fi does blocking at the back end PHY, right? You could imagine doing that, but hopefully not, right?
I think we should discuss in Detnet, in the working group, what do we do? I mean, okay, so now here come the per stream QoS functions, and only wanted to explain these. So the first one is the per stream filtering and policing. This is a kind of an ingress port, or that's a typical implementation case. It's of course optional where you implement. It is protection against bandwidth violation, malfunctioning, or attack against attacks. So there are three components or 3 possibilities here. The first one is the stream filter on the top, which includes filters or counters. These can be per stream, per priority. So there are multiple options. And if you want to block some stream, for example, this is one of the knobs for that. The next one is the stream gate, which can be open and or closed. And for example, you can close the gate if you discover a bubbling idiot in the network or something like that. This opening and closing can be time scheduled as well. And the third one is the metering function, which is based on the MEF bandwidth profile. This is a red, yellow, green marking. And we have actually added some other functions in this QCI standard, like if the frame size is over the larger than the max frame size, or something like that. So there are some new add-ons to that. Frame application and elimination, we have already discussed this. I don't want to spend time on it. Is this per packet redundancy mechanism. And we also have the capability for stream transformation, which can be implemented by the host or by the edge node. It is, well, there are multiple uses for that. One is this, the replication and elimination, but what we talk about here is the stream identification transformation. So if a different identification scheme is used by the network and the end station, this is one of the tools in order to translate between the two, like between an IP identification and the layer 2 destination MAC and VLAN stream identification. And now zero congestion loss. This part you wanted to explain.
Thank you.
We have two ways of achieving zero congestion loss. One is based on shapers, one is based on time scheduling. Asynchronous traffic shaping is a project that is underway now. It's not finished, but we've had some good presentations, some good simulations, and some experimental implementations. And it's enough similar to what you're familiar with individual queue shaping that you can appreciate it's got a good chance of being correct. It's a slight advance. We're all familiar, well, many of us are familiar with the idea that as the various flows come into a router, you put each one in its own shaper. And that by shaping the flows, you can get extremely low or even zero congestion loss. And we all understand that's not trivial in the number of gates required. What this idea brings to the party, a slight difference, is that we still need a state machine per flow for regulating, for shaping it, for regulating it. The difference is you don't necessarily have to have a queue per flow. You can take all the flows that are coming in on one port and going out on the same port and put them all through the same queue, and as each packet comes up to the head of the queue, you pick the shaper that goes with that packet's flow. So you have one queue and you swap in and you use the shapers in sequence. You have all the shapers running and you apply the shaper to the queue at the head. And if it's not time for that, you wait until it is time, then you transmit it, then you pick up the shaper for the next packet. And you get the same results as if they were in, actually somewhat better results than if they were in all different queues. So it's a cute idea. Feel free to look at it. We have had a credit-based shaper for some time. It is similar to the usual shaper you see in IETF. The basic difference is that the max burst size falls out of the other parameter. It has only one parameter, which is bandwidth, that you want to output, and the max burst falls out of that and is computable from that. But it's basically familiar to what the sort of things you are used to. This diagram shows how it's used. It shows two of our typical mechanisms. You have up to 8 queues. You don't have to have 8 queues, of course. You have up to 8 queues. Some of them may be running a weighted fair queuing algorithm. Some of them may be shaped with one of these shapers. That could be the asynchronous traffic shaper I was talking about a minute ago. It could be this traffic shaper. Well, sort of. Actually, that applies at a higher level. Sorry. But you'll notice the numbers there are the layer 2 priority values. That's, of course, in a bridge, what you're theoretically used to select a queue, as we all implement. That can be anything that you use to select the queue. But you'll notice priorities 2 and 3, which are the 2 priorities that we're running these shapers on, are at the far right. That's because they have precedence over priority 7. The priority, layer 2 priority, or diff serve code point, whatever, is used to select the class of service. That doesn't mean that priority 7 is ahead of everything else. If you're doing shaping, the shaped queues go out before priority 7, because otherwise they don't work. And one of the nice things about any of these shapers is that having shaped the highest priority queues, that gives you a guaranteed worst case latency for priority 7. And you can adjust that so the priority 7 does get out. The other method that we use, which is not based on shaping, is based on schedulers. 802.1 QBV, which is now a standard. It's now a published standard. In fact, I think it's been 6 months, so it's freely available from IEEE. You don't have to pay for it anymore. What we have is below the 8 queues, we have a row of gates. And these gates are controlled by a schedule, and basically every gate is either 0 or 1, open or closed. The way we think about, and the way we're talking about this diagram here, is that every queue has a bit that says, I have something, I'm not empty. That signal comes down, weighted fair queuing picks one of those to present down the path. The shapers will say, yes, I understand you have something, but it's not time to present it yet. It's not your turn yet. So these can be thought of as filtering the I have something to transmit. These guys are coming through unfiltered. The time gates are open and closed. If it's 0, the fact that you have something to transmit doesn't matter. If it's 1, you're allowed to pass through the fact that you have something to transmit. Then priority selection starts at the right and picks the first one that it sees starting at the right. That's the one that gets selected for transmission, and that's the one you pick a packet from to transmit. These gates allow you to do all sorts of things. I can say, only this queue gets to go at this time, only this queue gets to go at this other time. I can have critical functions. I transmit them at this time, I don't transmit them at this time. I can reserve one of these queues for a particular flow. Say, at this moment, I want to transmit from that flow so that I can get essentially 0 latency variation. I can say, enable one thing that a lot of people have said, oh, but this doesn't allow. Yes, it does allow for this. I can say, the only queues that are allowed to go are this one critical queue and all of the priority queues. And the critical queue, of course, is higher priority than the normal best effort queues, which means that if I have a critical packet, it will go. If I don't have a critical packet, then one of the best effort packets will take its place. So you get a lot of flexibility with this schedule. The schedule operates on a nanosecond basis, and it's supposed to be time synchronized so that it stays pretty close with all of the other all the other relay nodes queues. You can use the output scheduler to control latency to nanosecond precision. If your implementation is that accurate, it allows for implementations of whatever accuracy you have. But clearly, with only a few queues, it's not trivial to isolate particular streams or particular packets if you only have 8 queues. If you can't figure out what to do with that, you're not too bright. how to improve that. Other uses, we can use that to timeshare a link or a network. We can use it for cyclic queuing and forwarding. What is cyclic queuing and forwarding? I'm glad you asked. Another way of achieving fixed guaranteed end-to-end latency is this. We use these various techniques in combination. In this example, I'm using queues 2 and 3 as a pair, queues 4 and 5 as a pair. I run the time schedule to say alternately, let's just talk about one pair. Alternately, 4 or 5 is enabled, never both. And I swap them back and forth. While 4 and 5 are enabled, also the best efforts are also enabled. So if I don't have any critical traffic, the best effort gets to go through. What I do is I synchronize all the relay nodes. At each node, the critical traffic is double buffered.
Norm, just 10 minutes until the end of the session.
Okay. So, and what I'm doing is I'm filling one buffer while I drain the other buffer. Every packet spends one cycle time sitting and then gets transmitted. So my end-to-end latency is the cycle time times the number of hops. It's that's another technique we have that doesn't involve shapers. Next is transmission preemption.
Okay, so the way preemption works is we've got traffic that's express traffic, and we've got traffic that's identified as preemptible traffic. And this is per hop, so it's not like IP fragmentation. Basically, you may stop transmitting a preemptible frame while you transmit some express frames, and then you'll pick up transmission of it, and the MAC will basically hold on to the frame until it's got the whole frame. So the only thing that comes into and out of the MACs in this case is whole frames. So the scheduled traffic is like rocks in the transmission time. It's immovable. Now you'd like to use as much of the rest of the time as you can to transmit efficiently the other traffic, the traditional traffic. If you didn't have preemption, basically what you'd have is what you see in this figure, which is, okay, I've transmitted packet 1. I would like to transmit 2, but there's not enough time. I can't transmit it. I have to wait and just transmit this. Oh, here's another gap, but it's not big enough for packet 2 again, so I just have to sit on it. Okay, now I've got enough time to transmit it. That's not very efficient. So what we do with preemption is we allow the preemptible traffic to fill in the space between the rock, like sand filling the space. So basically, now with preemption, I can go ahead and start packet 2, transmit the scheduled traffic, then resume 2, start 3, scheduled traffic, finish 3. So it lets us utilize all that space between the rocks. So the other issue we have is that you can't preempt a frame immediately. It takes some time to actually realize you've got another frame there, preempt it, have an IPG, and then let the traffic start. We would like to be able to transmit scheduled traffic when it's going to be there. So we would like to go ahead and preempt ahead of time. So we have a primitive called hold that comes down through the service interface and says, I want to preempt. So there's no packet here yet, no express packet here yet to send, but hold causes the preemption to take place. The packet gets preempted, you have the IPG, and then the scheduled traffic can go, and then maybe you have a few scheduled packets to send, and then you get release, and then you can go ahead and after the interframe gap, go ahead and restart transmission of the packet that you interrupted. So basically, again, this is allowing us to make the most of that space while keeping the scheduled traffic undelayed. And here's a picture of how it fits in with the queues that Norm was talking about. So the scheduling is up here, and all the queues are up here, and the gates. We have two MACs, one that's handling the express traffic and one that's handling the preemptible traffic. So as I mentioned, only whole packets are crossing the MAC service interface. And then it comes down here to this MAC merge sublayer, which is what actually implements the preemption. And the fragments only exist on the wire in the physical layer between the two MACs. And the receiving MAC then, once it's got the whole preemptible frame, it goes ahead and transmits it. It sends it up to through the service layer to what's above it.
Pat, when you say you have two MACs, is that just for modeling, or are you actually going as far as having two addresses?
It's one address.
Okay.
But the logic that exists
So it's a
in the
model.
MAC,
It's a model.
yeah, the logic that exists in the MAC is theoretically there twice. Now, actually, you don't really need to duplicate all the gates, but what you do need to duplicate is all the variables that handle the transmission of the frame. So it is very much like because you're transmitting an express frame and you've got a preempted frame that you're holding on to, it's very much like you have two frames being processed at the same time. Bits are only moving from one of them at a time, but you have all the state to preserve about the preempted frame as well as the state for the express frame that you're transmitting. So in terms of the state variables, it is very much like you have two MACs. So I think if one applies oneself, one can see that one doesn't actually have to duplicate all the silicon. One just has to duplicate the state.
Thanks.
Okay. All right, and then there's some things we have no time to talk about. Did you want to get up and do the last slides?
Yeah, so the configuration part, this is mentioned in the flow information model. Really, we are running out of time. That we have a distributed reservation protocol, and I wanted to get to the summary and the discussion. So, as we explained, we have some new queuing techniques in TSN, and we are combining two different approaches: the per stream filtering, shaping, and time-based transmission. And for the certain time and/or mission-critical applications, all these techniques should be available for both Detnet and TSN. So here comes the discussion that okay, a flow need the same or similar treatment in a TSN or Detnet domain, and we discussed that TSN can be an underlay or a LAN can provide it between the routers, or it can be a service provided by Detnet. So both are in scope. And how do we achieve that, or how do we have leverage these all these features when we have both Detnet and TSN? So that was one of the discussion items we have in mind. Pascal has dropped another one. I don't know how much time we have for the discussion, or
I think you have 1 minute.
John Dowdle. Really quick question. Fascinating presentation. Thank you. Is there any open source code stuff available for what you've been doing in TSN?
well, for the CB, pseudocode is there in the document.
We have pseudocode.
Mike, please. And maybe you want to answer for the demonstration also.
Well, for the demo is our source switch is our own, so we don't have that open, and we just took the code from the document. But that's just the replication function, and I'm not really aware of open source yet on the other features. So I'm talking about this one.
Okay, thank you.
We may have time for one more question. Well, thank you very much. That's helpful. I think if you could send out a pointer to where your service definition is and traffic parameter definition is, that could help some of the information model discussion. So that would be really good. And we understand that there's a way to access that, and it's pretty well known how to find that access information. Thank you very much for participation and the good discussion. We will be doing the first stage of the adoption poll for the data plane solution, so get ready to send your comments. We're also likely to start moving forward with the information model with an adoption poll, and that mainly as a forcing function to see where we are there, engage the working group's feeling on it. With that, we will see you at the next IETF. Thank you very much.
Again, there is a demo of this one in the coffee break in the afternoon.